Hey everyone, welcome back to my YouTube channel where we learn to be a better programmer. And this video is part 5 of my Intro to Java video tutorial. And in this video we're going to discuss scoping, operators, and expressions. Before we get started, be sure to hit that subscribe button so you don't miss out on the next part of this series. Okay, so here I am in IntelliJ, and I've created a package called scoping and a class called scope. So scope is how we define where code lives in Java. Okay, and scope is defined by curly braces. So we would say that anything inside of these curly braces that denote the class scope would mean that it belongs to that class. It is a part of that class. It is in that class's scope. So if I were, say, to declare a variable, let's call it int my integer, then we would say this integer is a part of the class's scope because it's in the top level scope. Okay, so the top level class scope. Now, if I were to, say, define a method, so public void my method, doesn't take in any parameters, and I instantiated another integer, my method integer, and set it equal to 0, this value my method integer is local to the my method scope. It's not a part of the global class scope like my integer. So it's very important to note that I can access my integer variable inside of the my method. So I could say my integer is equal to 5, and we see how it lights up. So this class variable, we call these fields that are a part of the class. They're called fields. This field can be used inside of any method. But if, for example, I created a second method called public void my second method, and I tried to use this my method integer. So if I try to say my method integer is equal to 5 again, we get this error. So cannot resolve symbol my method integer. Okay, so that means that there is no variable defined with this name, my method integer, inside of the scope of my second method. So for example, if I instantiated another integer calling it my method integer, I could define it again because it is local to the scope. However, if I instantiated a value called my method integer and set that equal to 5, this still works. So how does Java know to differentiate between the class variable, the field, and the local variable? So it's very simple. The way you differentiate between the two is you say this dot my method integer, and that references the variable in the class scope. Okay, so it's very important to know that difference. This is dealing with so if I set this to 6, for example, this is talking about the field variable, so the variable defined in the global scope of the class scope, called scope. And this value is local to my method. So when you are dealing with scoping, it's very important to understand where your variables are coming from. So a rule of thumb that I follow, if I'm dealing with, if I have fields defined in a class, I will try really hard not to have name collisions. Even though they're not necessarily colliding, they're not causing errors. I really would try to name this something different. I would say, I would say, my method int, just to be a little bit more explicit to differentiate between the two. But if I can't, if for some reason I find myself not being able to do something like this, I then just prepend a .this to denote that I'm talking about the field variable and not the local variable. As you can see, it's not necessarily required. So it's not necessarily required because I didn't put this in front of my integer, which is a field up here. But if I were to remove this, it's ambiguous to which one I'm using, but just know that it's using the my method integer that's local to the method by default. So that's something that you should really try to understand about this. Okay, so and another rule of thumb is that we want to define and declare and instantiate variables as close to where they're being used as possible. Okay, so for example, if I wanted to do some quick math and I wanted to say, I'm just going to rename this to my local integer. I would just say, and I wanted to print something out to the screen, so I'd say system.out.println my local integer plus 5 or something. So this is going to print out 5. So we're defining and declaring a variable as close to where it's being used as possible. So when you define a field in Java in a class scope, what that usually means is this class's variable is going to be used throughout all the methods in that class. Okay, so it's more advantageous to treat a variable as a field that's going to last in the state of the scope class rather than lasting locally within a method. So it's kind of a way of having a variable live as long as the class lives and not necessarily as long as the method lives. Okay? Awesome. So that's all I wanted to talk about scope. So now we're going to move on to operators. So I've created a new package called operators, and then I've also created a class called operators. So Java has several different types of operators that are used across the language. So there are arithmetic operators, so arithmetic. So that's like your plus, minus, multiplication, division, mod, and modulus. There's assignment. So assignment could be like when you assign a value to a variable. There's plus equals, there's minus equals, there's divided equals, there's times equals, there's mod equals, and so on. We also have comparison operators. So comparison operators would be less than, greater than, less than or equal to, greater than or equal to, equal to, not equal to. And then we have some logical operators. So logical. This is how we compare if two statements are true. So we have, or true or false or something like that. So we have and, we have or, and then we have not. So there's also bitwise operators. So bitwise are how we manipulate the bits of an actual object. I haven't talked too much about that. Don't worry too much about it, but there's the bitwise and, there's the bitwise or, there's the XOR, there's the shift right operator, and then the shift left operator. These are used to manipulate the bits of a value. Okay, so let's create a main method. Arithmetic is pretty straightforward. So, but in order to use them, we need what is called an expression. So you can't just say in Java, you can't just say 5 plus 6 because that's not a valid expression. Okay, so an expression, you need to actually do some sort of assignment during that line, or some type of action. Okay, so if we're doing math or arithmetic, we need to have a variable. So let's create an integer, my variable, and we're just going to set it equal to 0. Okay, so I'm going to go through modifying my variable using all the arithmetic operators. So I'm going to say my variable is equal to 5 plus 5. So that's going to print out, that's going to be 10. And then I'm going to say my variable is equal to 5, or my variable minus 5. So it's basically taking the my variable value here and then subtracting 5 from it. So this is actually just going to print out 5. And then I'm going to say my variable is equal to my variable times 2, or times 3, just to help ourselves. So this is going to be 15. And I'm going to say my variable is equal to my variable divided by 5. This is going to be 3. Okay, and then lastly, I'm going to say my variable is equal to my variable modulus 4. This is actually going to return 3, because when we try to divide 3 by 4, we get a remainder of 3. While you can do this longhand, it's a lot cleaner and a lot neater to use these assignment operators as well. Okay, so I'm going to create two new variables here. We can do some comparison on these objects. So I'm going to say system.out.println my integer is less than my double. So this is actually going to let me just change this, my double. So this is going to print out true. So I can do system.out.println my integer is greater than or equal to my double. This is going to print out false. If I were to say my integer is equal to 10, and then I can say system.out.println my integer is less than or equal to my double, this is going to print out true. You can also say system.out.println to my integer is less than or equal to, or is equal to my double. So this is going to print out true as well. Add a new line, and I just say my integer is not equal to my double. This is going to be true. Okay, so these are the comparison operators. This is very useful to understand how these work. Now we go to our logical operators. All right, so let's take a look at this. So logical operators are very straightforward. It's a nice way of chaining these sorts of comparison operators together to get some sort of output. Say I have two booleans. If I say system.out.println is true and is false, this is actually going to print out false, because is true and is false. So this AND statement requires the operands on both sides of the AND are true. So if I were to do this, and I say not is false, then this would be true. So let's see what IntelliJ is saying. This is always false, and then this is always true. And then or, so if I say instead, so if I say system.out.println is true or is false, this is going to print out true, because it only requires that one of the operands be true. Let's just do a quick recap. So arithmetic operators are how we do addition, subtraction, multiplication, division, and modulo. Assignment operators are how we modify a variable. So we can say just set a variable equal to something. We can do plus equals, minus equals, divided equals, times equals, and mod equals. Those are all examples of how we can modify the value and then return it and assign it to a variable. The comparison operators are just how we compare two numbers. So less than, greater than, less than or equal to, greater than or equal to, and not equal to. Logical operators are the and, or, and not. So and requires that both statements be true, or requires that one or the other, or at least one statement is true, and not is just how we flip the truth of something. So if something is true and we not it, it becomes false. If something is false and we not it, it becomes true. Okay? All right, thanks for watching. Be sure to like and subscribe to make sure you don't miss out on the next part. Thanks. Bye.